Hello students, I hope you all are well. Today in this video, I'm going to explain your end of term for term 2. So let's start the very first thing which is there. Explain the motion of horizontally launched projectiles and show schematically the components of velocity and acceleration throughout the motion. Here you can see they are talking about the horizontally launched projectiles. I explained you before that the projectile can be of two types. One is horizontally launched and another is angle launch. So I'll explain you that thing one by one. So let me proceed for the whiteboard. When I'm talking about the first thing, that is horizontally launched, 1 minute. Horizontal launched. In horizontal launched, you have to throw an object from a certain height. So if you throw any object from a certain height, let's say h, the block or the object will fall like this. Yes. So in horizontally launched case, what are the different positions you can consider? So let's say the different position, let it be here. So the velocity component you can show like this. So there are the velocity tangentially, you have to show that. So first thing what you need to explain here, the two kind of motion. One motion is called horizontal and one motion is called vertical. When we say something is horizontal, when there is left and right, means you are going left or right, it will be called as horizontal motion, means you are going there, here, there, like that. Vertical means up, down. You are going up and down, that is called vertical motion. So if I'll ask you here, where is vertical, where is horizontal, so you can easily say like Mr. C, this is horizontal and the other side, this one is vertical. So we can say like this is x-axis and this is y-axis, horizontal and vertical. Now it is a horizontal launch, so if I'll ask you to draw the components, how you can draw the components over here? The first thing is initial velocity in horizontal, x for horizontal. It is constant, it means the final velocity in the horizontal, it will be constant. The horizontal velocity will not change because it doesn't have the effect of gravity. And if I talk about the initial velocity in vertical direction, here initial velocity in vertical direction, it is 0, it is for y. Yes, this is at the very initial position I am talking about, very initial. Okay, so very initial means I am talking about very initial here. Now the object reached here and here. So if the object will reach here, you can draw the component x, you can draw the component y. You can draw the component y, you can draw the component x. Yes or no? This is x, this is y. So we can say this x as, if the velocity is v, if let us suppose the velocity is v, so this component will be vx and this component will be vy, vx, vy. Now if this angle is theta, this angle is what? Theta, it is something like representing angles. It is representing what? Angles. Okay. So The theta is along with the x-axis, that's why we'll take cos here. So it will be v cos theta, and here vy will be v sin theta. Vx is equals to v cos theta and vy is equals to v sin theta. So this is, you have drawn the components. This is called what? Components. Horizontal component and vertical component. So if I'll ask you what is horizontal component over there, it is vx cos theta. Yes or no? Or you can say v cos theta. Yes, simply you can say v cos theta, that is vx. What is vertical component? Vertical component is vy, which is equals to v sin theta. Correct? Now what about the horizontal component? Horizontal component remains constant. It is constant. What about vertical component? The vertical component is increasing, but initially it was 0 here, then it starts increasing like this. Yes or no? So it will be increasing. It will be increasing. Yes. So in this case, if I'll ask you to draw the motion diagram, this is the motion diagram. Okay. Or you can simply, in the book, you can find it out. They are making the x like this, vx, the x like this, vx, the x like this, vx, and the same way here they are representing the y also like this, vy, vy, vy. So this is the motion diagram. This is what? Motion diagram. Correct? So if you understand this, here, based on this horizontal launched projectile, there are two questions they have mentioned over here. What are the two questions? The first question is, the base balls are pitched horizontally from the same height, but at different speed. The faster ball crosses home plate within the strike zone, but the slower ball is below the batter's knees. Why do the ball pass the batter at different heights? So it's very simple to understand. Let us suppose if you are throwing a ball from a same height, in the first case, and there is another case. Let's say here I am making two cases are there. So first you are throwing at the high speed. So high speed it will go far. Let's say it is having a velocity v1. Another, you are throwing with a lesser speed. So lesser speed it will go down. If the batter is here, he is playing it. So it is falling here at his knees only. So it means the effect of gravity means the vertical velocity. This is vertical, yes. So vertical velocity is not affecting that much in the first case. Yes, that's why it is having a less effect. Yes, less effect of vertical component. Yes or no? Or vertical velocity. If it has a high velocity. But if it has a low velocity v2, okay, it means it has a high effect. It has having high effect. High effect of vertical velocity. So what does the answers? The faster ball is in the air a shorter time, correct? And thus gains a smaller vertical velocity. Means it is a less effect, so it will be having a less vertical velocity. Okay, smaller vertical velocity, and it will take shorter time also. But if it is with the lower speed, it will take more time, correct? So once it will take more time, it means it has a high vertical velocity component. Yes. So this is how you can explain it. Now the next question. The next question is, you have to draw the free body diagram. There is an ice cube slides without a friction across a table at a constant velocity. It slides off the table and lands on the floor. Draw free body and motion diagram of the ice cube at 2 points on the table and 2 points in the air. It's very simple to make it. it's already drawn here, but I'll make you understand here also. Let us suppose there is a ice cube, it is on the table. So if I'll ask you draw the free body diagram, if you need to draw free body diagram, how you can draw it? First of all, you have to make its weight, which is down, which you can represent force of gravity Fg or W, which is equals to mg, and with the same line you have to show its normal force Fn. Yes, there is no other force, yes or no? So that's on the table, it will be like this, correct? So that's why on the table you have to make like this figure, correct? When it moves to the another position here, let's say here it comes here, so it will be like this, correct? Same. But when it starts falling from here to here, it will come this point, it will come this point. So it means it has having only the force of gravity Fg and Fg, correct? So that's how they made it in the air. So this part is in the air. This part is in the air, sorry. This part is in the air, yes. So that's what they have written. So this is free body diagram. Now another side they are asking motion diagram. So motion diagram you can explain it in the same way of the projectile. How? See, the motion diagram can be made from here in the same way. Let's say the object becomes here and it starts falling like this. So take its two positions, here, here. How the velocity will be like this, how the velocity will be like this. Draw the component, how the component will be, this is x component, this is y component, x component, y component, yes or no? Let's say this is angle theta. Write the component, this is Vx, so it will be V cos theta. This is Vy, it will be V sin theta. This is Vx, it is equals to V cos theta, which is constant. This is Vy, which is equals to V sin theta, correct? So how you can show the velocity? It is like this. Where is the acceleration? How the acceleration will work? I told you before that horizontal component velocity is constant. So it means horizontal acceleration ax is equals to 0. Yes or no? Because it is constant. So a is 0. When the object is here, you can simply say that a is 0. A is 0. Simply this one. Correct? When object starts falling, you can see here y component, x component, y component, x component, y component, x component, y component, x component. So it is making like this only. Correct? The same. And acceleration will be down, which is equals to minus g. Value is minus 9.8 meter per second square. This is the acceleration. I hope you understand. So this is the diagram they are asking about the situation. Yes. Let's proceed with the next one. The next question is, define the friction force as a type of force between two touching surfaces and determine its direction. They are asking to define the friction force. So if I'll ask you what is friction force? So friction force is something which always acts opposite to the applied force direction. Yes. So here they have explained you about kinetic friction. Okay. But if you want to explain your answer like that, you can start from the friction. Okay. If you want to explain in proper way, I'll explain here. 1 minute. So first of all, what is friction? Friction force. Two things. First is friction force is always applied in between the two surfaces. In between the two surfaces. The second thing is friction force is always applied in the opposite direction of the applied force. The third thing, friction force is defined as the product of coefficient of friction and the normal force. What is this? We need to understand. Now here I introduce the term coefficient of friction. This coefficient of friction is represented by mu. You are making u, yes? So just make tilt like this. So this is called mu. Okay, this is a symbol to present coefficient of friction. Coefficient of friction will be different for different materials. It will be different for different materials. It will be different for different materials. For different materials, or you can say different surface. Okay, different surfaces. So to make it understand in a proper way, let's have a situation. Okay, what is the situation? Let's take any object which is lying on a floor. This floor is having a coefficient of friction mu. If I'll ask you to draw the free body diagram, let us suppose if the force is applying in this direction, this is the force applied. Where is the direction of weight? It is downward. W is equals to mg. You are also calling it force of gravity, Fg. This is very small g. This is just a subscript. Okay. What is the normal force? The normal force will be just opposite to it. Correct or not? So how you can draw the normal force? It is just opposite to it. Fn. Correct. Now what is the direction of the friction force? Motion will be in this direction. Correct. If the body is in motion. So the direction of friction will be just opposite. Yes or no? So this is the friction force. This is the friction force, which is equals to mu s Fn. So what is the formula of friction? Friction force F is equals to mu s, this s I will put it when there is a static friction, or simply write mu, okay, Fn. You can simply write mu Fn. This is the formula, and the unit is SI unit of force is Newton. Correct. Now here you can relate two situations. What are the two situations? The two situations are, this friction force can be of static, can be of kinetic. Static friction means body is not moving. Kinetic means body starts moving. Yes. So for static friction, we are saying it is Fs, and for kinetic friction, we are saying it is Fk. So for this, the formula you are writing Fs is equals to mu s Fn. And for this, you are writing Fk is equals to mu k Fn. It means here this mu s is called coefficient of friction, coefficient of static friction, coefficient of static friction. And here this mu k is called coefficient of kinetic friction. Okay, now always remember the value of mu is always less than or equals to 1. It can never be greater than 1. Okay, now if I ask you to calculate the value of coefficient of friction, mu s can be fs over fn. This n will go down, so the formula will be fs is equals to mu s is equals to fs over fn. From here mu k is equals to fk over fn. So this is the formula of the coefficient of friction for static and for kinetic. So that's it. What in the question I made you understand the formula also, and for mu there is no units. Okay, so this is how you can explain in between the two surfaces the friction force. I think it is clear to all of you. So let's come back to the question again. So here also it has been explained like this. They have taken the example of sofa. I explained with the example of the block, and the things are the same. Next question. Recall that for an object to be in equilibrium, the net force acting on it should be 0. So for this question, the object to be in equilibrium, what does it mean? The object to be in equilibrium means the net force must be 0. The net force must be 0. So I'll explain you here. The object force must be 0 means they are talking about the state of equilibrium. So anything to be in equilibrium, it means the net force must be 0, the acceleration must be 0. If any object is there, if it in the situation that there is a net force 0 and acceleration 0, we will say the body is in equilibrium. What does this mean? It means when we will say that net force is 0, it means that the body is balanced. The body is balanced. And we'll say acceleration 0, it means two cases. What are the two cases? Body is at rest. When the body is at rest, then acceleration 0. And the another condition is body is moving with constant velocity. Body is moving with constant velocity. So if the body is moving with constant velocity, it means initial velocity will be equals to final velocity will be v. So a is equals to change in velocity over time, correct? So vf minus vi over t. So both velocity is same, correct? So it will be cut and it will become 0. So there will be two situations for the acceleration to be in 0. If the body is at rest, you can say if the body is at rest, and another case is the body is moving with constant velocity. So equilibrium condition can be achieved in at rest position also, even at constant even in motion also, if it is moving with constant velocity. So let us suppose if any object is there, you are applying a force from here F1, you are applying the force here from F2, you are applying the force here from F3. All the sides you are applying the forces, and if the net force, if I am saying I have applied the net force over here and it becomes 0, sum of all the forces becomes 0, then we will say this body is in equilibrium. This body is in equilibrium. So that's why when you have to apply the equilibrium condition, you need to have the condition like sum of the forces means sum of the forces in horizontal direction or in vertical. It must be balanced. It must be balanced. So it must be equals to what? Net force. It must be equals to what? Net force. Net force is always equals to ma. If the body is balanced, we can say that is 0. Correct? So this is how you have to explain this answer of equilibrium. So you can see here they have explained in the same way, constant velocity and all, and they gave you the example like this. Okay. Now question number 4. Solve problems related to friction. Solve problems related to friction. In this question, you can see they are saying you want to move 41 kilogram bookcase to a different place in the living room. If you push with a force of 65 Newton and the bookcase accelerate at 0.12 meter per second square, what is the coefficient of kinetic friction between the bookcase and the carpet? Between the bookcase and the carpet. So here what we can see, there is a block of 41 kilogram bookcase. It's a mass. So you can simply make a diagram. This is a block, okay, or you can say bookcase whose mass is given 41 kilogram. So given, I will write here given also. So given is mass 41 kilogram, correct? Also it is giving you a force which you are applying, F applied, how much? 65 Newton. They have given you the acceleration also, A is equals to 0.12 meter per second square. They are asking you coefficient of kinetic friction, means they are asking you mu k. So first of all, the question is something like mu k you have to define. So what is the formula of mu k? If you go back, I explain you the concept of friction. What is the formula of mu k over here? Fk over Fn, yes or no? So you have to apply the same force, the same formula. You know that mu k is equals to Fk over Fn. So you need to find normal force as well as kinetic friction force in this situation. So let's begin with this diagram. So this is force of gravity which is equals to mg. M is given 41 and G you know that 9.8 meter per second square. So that you can calculate over here if you want it, or you can take simply mg. At last we can put the value. Another thing is the normal force which is acting opposite to the weight. It is pushing by the force, so you are pushing it. So it is a push force. How much? F applied is equals to 65 Newton. So definitely the friction will be in opposite direction. Force is applying here, so the motion is in this direction. So the friction force Fk will be in opposite direction. So if I'll apply the equilibrium condition, what it will be? There will be two cases, yes or no? What are the two cases? First is the vertical force Fn and Fg. So take up one plus, down was minus. So what you can write? Plus Fn minus mg is equals to 0. So Fn is equals to mg. So Fn you can write mg, which is 41.9.8. So that you can calculate Fn and you can put it here. Yes. So in the solution you can see this is actually in the form of Fk over Fn. So Fn is mg, that you can calculate. Now the another is horizontal forces. How many horizontal forces are here? 2. One is this one is this one. So always take, because the body is in motion, so I always said that the net force is not 0 here. You have to take ma in motion. If it is at rest, then acceleration 0, you have to take 0. So vertical direction, no motion, but horizontal there is a motion. So how you can do? Always take plus in motion, in the direction of motion. So this is the direction of motion. Take this side plus this direction and opposite side minus. So see, this direction is Fa. Fa is in this direction, so take this as positive, and Fk in the opposite direction, take this as negative. So how you can write the relation of horizontal forces? you need to write plus FA minus FK is equals to F net, which is equals to MA. Yes, so FK will be equals to, if you shift FK over this side, if you shift FK over this side, it will be MA, means FA minus MA. F applied, this is applied, F applied minus MA. So this is the formula you get for FK. Yes, simple. So this is the formula, they put it over here directly, F minus MA. Correct? So this F, you know that it is how much? 65 Newton. You put 65 minus mass is 41 kilogram, it is given. Yes. Then acceleration is given 0.12 meter per second square, you put it. M is 41 and G is 9.8, you have to take. Put the values, you will get the answer. So the way which I told you, it is the concept that you can apply everywhere, okay, to solve the questions. So let's begin with the next question. Question number 20. What is question number 20 here? It is saying that consider the force pushing the box in example problem 4. The problem 4 was there before in the book. How long would it take for the velocity of the box to double to 2 meter per second square? It means they are asking you how long. How long means it is asking you time. So time you will get it from the equation of motion, if you can apply. So see that what are the things given. In example problem 4, they have given you mass. They gave you the resultant acceleration 2 meter per second square. How far will you push the box if you push it for 3 seconds? So they asked previously question like for 12 meters. So it is not asking here. It is asking you how long would it take for the velocity for 2 meter per second. So initial and final, in both the way we have to take it like that, okay. So what is how long it will be like this. So you need to find the question, find the question accordingly. So if you are pushing the box, let us suppose box is there, you are pushing it. So in this question, what are the data given? Given data. The given data is how long would it take for the velocity of the box to double to 2 meter per second. Double to 2 meter per second. Means if it will be double to 2 meter per second. So double to 2 meter per second is, if it is 2 meter per second, it will be 4. Yes or no? So if it is saying double to 2 meter per second, this is a little mistake over here. So you have to take initial velocity. If the initial velocity is 2 meter per second and final velocity will be double of it. So the final velocity of the double of it means 2 multiply by 2. It will be 4 meter per second. Correct? So if you double it, the problem can be of any type, okay. This is the problem which they have taken from the book. So the concept will be the same. So some of them they have taken 1, some of them they have taken 2, but what I understood, like if it is 2 meter per second initially, okay, so finally it will be double of it, so it will be 4 meter per second, correct? So if it is like that, how you can find the acceleration? Because the time you need to calculate, correct? So time, for doing the calculation of time, what is the actual formula we have? The equation of motion. First, Vf is equals to Vi plus At. Yes or no? So you need 4 meter per second square finally. Initially is 2 plus At. Time is given, time you need to calculate, correct? So in this question, if you get A, so according to the question, you can see the problem for it was already given you resulting acceleration, which is 2. So you can put it here 2. So 4 is equals to 2 plus 2t. Yes or no? So 4 is equals to 2 plus 2t. So how you can calculate? 2t is equals to 4 minus 2, which is equals to 2. So 2t is equals to 2. So t is equals to 2 over 2, which is equals to 1 second. So accordingly the answer will be 1 second. Okay. So I doubt on this question which I explained here. If you take initially instead of 2, if you take 1 meter per second, your answer will be 0.5, then it will be 2. Okay, but the method will be same. You don't have to get confused on such kind of question. You just stuck with what the question is saying. Okay, so this is something you need to solve. Now question number 5. Determine the components of a vector in Cartesian coordinate system using trigonometry. Now here they are asking you Cartesian coordinate system. Okay, so how this Cartesian coordinate system works? Cartesian coordinate system means Cartesian coordinate system. What does this mean? It means that if there is two axes, let's say there is y axis and there is x axis, x and y. Okay, take this direction, you know that this is plus, this is minus, this is plus, this is minus. If I'll ask you the quadrants, this is the first quadrant, it is plus plus. Always we are writing x first then y. This side x is minus, y is plus. This is called second quadrant. This is the third quadrant, here both of them minus, and this is the fourth quadrant. This is plus minus. So for example, if there is any vector like this, let's say a vector, so its component will be, how the component will be? This side, if this is theta, you can say this is ax, so this is a cos theta, and this is ay, so this is a sin theta, correct? So if I'll ask you in first quadrant, tell me how the Cartesian coordinate will be. So in first coordinate, ax means x axis, correct? So ax is positive, so you will write a cos theta. Ay is also positive, you will write a sin theta, no problem, correct? Now in the second quadrant, how it will be? Your x is minus, y is plus, so ax will be minus a cos theta, yes, and ay will be plus a sin theta, correct? Here tell me, ax will be minus a cos theta, ay will be minus a sin theta, both are minus. Here ax will be plus a cos theta and ay will be minus a sin theta. This is called Cartesian coordinate system, correct? And what I am doing, this is called resolution of component, breaking the components. So there is a term which is called resolution of vectors. I explained in the class already. Resolution of vectors means breaking of vectors into two components. X and y direction, yes or no? So this is what you are breaking, a cos theta, a sin theta, that is called resolution of vectors. Okay, so let's come to the question. So based on this Cartesian coordinate, I made you understand there is a problem. The problem is this question we have done in the class, if you remember. You are on a hike, your camp is 15 km away in the direction 40° north of west. The only path through the wood leads directly north if you follow the path 5 km before it opens into a field. How far and in what direction would you have to walk to reach your camp? Now here you need to know the concept of the vector also. Okay, so this question to solve, like 15 km away, you are on a hike and your camp is 15 km away in the direction 40° north of west. So what does it mean? It means that problem You know the directions, yes? This is north, south, east, west. So north of west, when we will say north of west, north of west. So this is the direction, yes or no? What is the meaning of north of west? Means we are talking about this direction. North and west, north of west. We are talking about this direction. So in the question it is saying, if you are going 15 kilometer, how much? 15 kilometer at 40 degree. At 40 degree north of west, correct? And also they are saying, in the direction 40 degree north of west, the only path through the woods leads directly north if you follow the path 5 kilometers before it opens into a field. Okay, how far, in what direction would you have to walk to reach your camp? So in this question they are saying only the way is if you move towards the north 5 kilometers. So the question is, from here, how much distance and in what direction you should go to reach to your camp? This is the camp, correct? Let us suppose this is the camp. So they are asking you this distance and direction. So simply what you can do, you just make the things like this is A vector, this B vector, you need to find it out and you need to find its direction, correct? Theta B, or you can say angle A. Okay, this is theta, they have already given you 40 degree, correct? So this is your resultant then. So R is given, A is given, B you need to find it out. So as you know that there is no right angle triangle, so no need to think even for Pythagoras theorem. Here you can apply the law of parallelogram, but if you resolve the components then only. So how you can resolve the components? All the vectors you need to resolve. So first of all, if I'll ask you about this resultant vector, we take the red color. The resultant vector, this one, it can have two vectors, yes or no? In this direction, in this direction. So it has a vector Rx, which is equals to R cos 40 degree, yes? And there is Ry, which is equals to R sin 40 degree. Very clear? Now for A vector, there is no x axis because it is straight forward, yes or no? So it is only having a vertical component, which you can say this is actually Ay. This is actually what? Ay. There is no x. So if there is no ax is 0 in this situation, yes or no? Only Ay. Now let's see the B vector. B vector having a two components because it is an angle theta, or sorry, angle A. You can resolve the component like this. One component will be here, one component will be here. So this is a Bx, which you can write B cos A, or let's say this side, this is By, which is equals to B sin A. A is the angle I took, okay? I'm just simply solving in a normal way, which I explained to you in the class, okay? One by one you need to understand each and every step. So let's talk about horizontal components. Horizontal components. What are the horizontal components? You have to sum Rx. So Rx in the direction, this is the direction of Rx, correct? There is no horizontal component for A, but there is a horizontal component of B, Bx, correct? So Bx is in the same direction of Rx, so you can write Rx is equals to, because Rx and Bx are in the same direction. So how you can find the resultant? Resultant will be equals to Bx vector plus Ax vector. So Ax is 0, so it will be only Bx. So Rx is equals to Bx, correct? Rx is equals to Bx, no problem, which is equals to R cos 40 degree. Yes or no? So R is how much? 15. So it will be 15 cos 40 degree. You can calculate it. That will be the value of Bx. No problem. Now just switch for the y component. What are the y components you have? You have Ry, you have By, and you have Ay, correct? So how you can write Ry vector is equals to, how many vectors are there? By plus Ay, correct? Now put all the values which you know. Ry is equals to R sin 40 degree. By you don't know, you need to calculate. Ay is given 5. So By will be equals to R sin 40 degree minus 5. Yes or no? So R is how much? R is 15. 15 sin 40 degree minus 5. So that will be the value of what? By. That will be the value of By. So if you calculate it, if you calculate all these values, what you will get? Let me put the calculator and I'll calculate for you. If you can do it, it will be good. So if you calculate it, you will get By vector is equals to 9.64 Newton and Bx is equals to 11.490 Newton. So what is the resultant for B vector? Because you need to find B. So B vector is equals to under root Bx square plus By square. Yes or no? So Bx you have calculated 9.64 square plus 11.49 square. So let's do that. If you do this, so you will get 12.4 Newton. Sorry, these units are, I think it is kilometer. Sorry, this is kilometer, this is also kilometer. So you will get this also in kilometer, correct? So this is the distance. They are talking about the distance. So how much distance you need to cover to reach to the camp? This one. This is 12.4. Now you need to find the directions. So direction of B. I explained you theta, which is I mentioned here A, which is equals to tan inverse By over Bx. So first is y and then x. So tan inverse By is how much we have calculated? 9.64 divided by Bx. Bx is 11.49. Calculate it, you will get almost 22 degree, which is equals to A. So it means you have to go to 12.4 kilometer at which angle? At 22 degree. This angle is how much? 22 degree. Understand that? So this is 22 degree angle you need to go to reach to the camp. So this is how you can solve the question in a simple way, step by step. So if you understand the method which is there in the PPT, you can go ahead. If you like the way which I have explained to you, that is also the same, without taking this 140 degree, by only applying this 40 degree, you can simply solve. Okay, so both the methods are now you have. So this is the problem 2 I have explained to you. Now let's proceed with question number 6. Use free body diagram to compare the direction of an object acceleration with the direction of the unbalanced force exerted on the object. So you need to apply free body diagram to compare the direction of an object acceleration. So related to that, there are some questions. A minute. The question is, the first one, a skydiver falls downward through the air at constant velocity. The air exerts an upward force on the person. You can see this is a picture of the skydiver. This is the system. So what are the force is applying here? There is a first force which is applying by the earth, that is the earth mass on the diver, and there is a resistance of the air because air is also applying a force on the body. So that is the air resistance opposite direction. Yes or no? So net force is 0. Understand? The next question. You hold a soft ball in the palm of your hand and toss it up. Draw the diagram while the ball is still touching your hand. So if there is a soft ball in the palm, okay, of your hand and toss it up. So if this is your hand and there is a ball on it. So first is what? The earth weight, means the earth mass on ball, and there will be a hand on ball. Your hand will also apply the force on the ball, correct? Opposite direction. So F net will be accordingly. Yes or no? So F net will be accordingly because you are tossing it up. So you are throwing it, means you are applying the force greater than the gravity. Yes or no? So if you are saying this is the force earth mass on ball. So mass on ball, correct? And this is the hand on ball, HB. So it means HB is greater than F on B. Yes or no? So it means the net force will be towards up because you are throwing up. So net force will be in the direction of upward. After the soft ball leaves your hand, it rises slowing down. So if it leaves, it will come down. So down means the earth mass on ball, the net force will be down then. You can see up, then it comes down. Now the next question. After the soft ball reaches its maximum height, it falls down speeding up. So once it will reach at some height, its velocity will be 0 and then it comes again to the down. So it will be same like this. So same like the upper one, it will be in the same way. Question number 7. Combine forces to find the net force acting on an object. Relate the direction of the acceleration to the direction of the net force. Now they are talking about the concept of the net force. So let's have a questions from the book. First is 34, interaction pair. Identify each force acting on the ball and its interaction pair in figure 20. If you remember, for the interaction pair, I explained you like there must be a symmetry. Like if it is FAB, so it should be FBA. And the another thing, there must be two different objects to form an interaction pair, correct? So here, for two different objects, the forces on the ball are downward force of gravity due to the mass of earth. So if this is the ball, okay, let's take the example, the first one. This is a book on the table. So action force is down, the reaction will be up. So this is the action reaction. If you are holding a ball on the hand, the ball is applying a weight of mg, means earth, and hand will also apply a force on the ball. So hands on ball and ball on hand. So here also the symmetry is there. So first is ball on hand will be equals to minus F hand on ball. These are the interaction pair. Yes. Another question is, a block hangs from a ceiling by a massless rope. A second block is attached to the first block and hangs below it on another piece of massless rope. If each of the two blocks has a mass of 5 kg, what is the tension in the rope? Now here in this question, you can see that there is a block of mass 5 kg and another is also 5 kg. Both are tied it up with this string. Yes, and they are asking you the tension. Okay, so how we can find the tension on this, that we need to see. Okay, so first is A second block is attached to the first and hangs below it on another piece of massless rope. If each of the two blocks has a mass 5 kg, what is the tension in the rope? So they are asking tension in the rope. So here for the bottom rope with the positive direction upward, for the top rope with the positive direction upward. Means in the solution they have taken two conditions, okay, top to up to down. If you apply simple free body diagram, that also work for you. How? If you see the two blocks, let's say the block first one is A and this is B. So if I'll ask you, can you tell me the free body diagram of the A1? So you'll say, yes, mister, this is the mass of A. So I can write here FA, which is equals to MAG. Yes. And there will be a reaction, means it is in the tension. So the tension is here. So this is for TA. Yes or no? This is for TA. Understand? Now the block B is attached with this one. So it is also having a mass, which you can say FB, which is equals to MBG. Yes. And it is also having a tension force on this. So this is having TB. So you need to find TB and TA. You need to find what? TB and TA. So if I'll ask you the combined one, okay, what is the net force? So if you apply both the situations over here, what will be the condition for the force? So let's make it in a simple way. Here I'm making the situation like this. Let's say here there is one block attached another block A, B. So let's talk about one by one both the situations. For A block there is a mass, correct? So this is FA, which is equals to MAG, correct? And there is a tension on TB. This body is in motion, so there is no motion, it is not moving. So F net here it is 0, correct? In the case 2, the upper one, this body mass, okay, it is also having the weight, means FB, which is equals to MBG, and it is having a tension that is called TB. Let's say this is TA and this is TB, okay, to make it more better, TB, TA. So make here free body diagram for A. So A is having only two forces, FA is equals to MAG, and there is a tension that is TA. So if you are taking this plus minus, so it will be TA plus minus MAG is equals to 0, because F net is 0, no motion. So TA is equals to what? MAG, correct? So you can easily calculate TA from here. So what is the value of TA? What is the value of mass they have given to you? Mass is 5 kilogram. So put the value 5. So it is 5 multiplying 9.8. So if you multiply 5 with 9.8, you will get 49. So it is 49 Newton. So you got the tension TA, correct? Easy. Now we need to make the free body diagram for B. For B situation, free body diagram for B. B is here. So for B block, there is a mass. There are two things, correct? The mass of itself MB, as well as the mass of A, because it is hanged with A. Yes or no? This A is hanged with B, so there is a mass of A also exerting on it. So it means it has two masses. So it means FB is equals to MA plus MB total mass and then G, correct? It has two mass effect and the tension is TB. The F net is balanced, so F net is 0. There is no motion. So how you will apply? Take this as minus, this as minus. So what you will get? Plus TB minus MA plus MB multiplied by G, correct? Is equals to 0. So TB is equals to MA plus MB into G. What is MA? 5 plus 5. Yes or no? Let's check. The both mass is 5. So 5 plus 5 multiply 9.8. So it will be 10 multiply 9.8. Correct? So you will get how much? 98 Newton. That's it. Therefore, tension on ropes. First is 49 Newton, which is at the down part. 99 Newton up. Answer. This is the way you can solve the question. Okay. The same type of question is already there. You can try by your own. If you are facing problem, you can ask me anytime, because here also they have given you the masses like that. Okay, so that you can try by your own. If you're not comfortable with this method, don't attempt it. Whatever the way I explained to you here, in the same way you can make the FBD and solve it. Okay, this is the easiest method. Okay. Now here relate the direction of the acceleration to the direction of the net force. In this question you have to relate the direction and acceleration to the direction of the net force. The concept is given to you. What is the concept? The constant rate of change of velocity means acceleration is constant. Like you can easily understand from this graph, it is between time and velocity. So you can see the purple color, red color and this blue color. The purple, it is having a less slope, 0.5. The red one is little more, and the larger one, it is 1.5. If I'll ask you to calculate the acceleration, how you can calculate? In velocity and time graph, the slope will give you acceleration. The slope will give you acceleration. So what does it mean? It means that how to find acceleration from VT graph. For example, this is the graph, velocity and time, and there is a point. So what you need to do, you have to take 2 points, correct? 1 point, 2 points. So this point, it is actually x-axis, this is actually y-axis. So this point will give you x1 and this one y1. Another point, it will give you x2 and this one will give you y2. In the first term we did it, yes? So how you can find the slope? y2 minus y1 divided by x2 minus x1, correct? It is actually what? It is actually what? T2 minus T1, V2 minus V1, correct it, V2 minus V1 divided by T2 minus T1, correct? This is the same way you can apply and calculate the slope. This will give you the value of acceleration. So this is the video first part. I made it. It is approximately for 1 hour, and in the next part I'll cover the rest of the questions. I hope you understand all the part of it.